given. So okay, let me explain the statement. So you will be given two arrays. So you will be given two arrays. One is num1 and another one is, there are two arrays. And the first array is a subset of second array. So let's say first array is 4, 1, 2 and second array is 1, 3, 4, 2. So first array is a subset of second array. So always the first array size is less than second array size. What is the ask is, um, we need to pick up an element from the first array. So for example, element 4, right? So look for element 4 in the second array and see, do you find a greater element? Okay, so element 4 is here. When you move on to the right, do you have a greater element? So as we don't have greater element, so definitely we need to return -1 at this place. And similarly for element second element in the first array is 1. So look for the element 1 in the second array, see the next greater element for 1. So the next greater element for 1 is 3, so that here we need to print 3. Similarly for the third element 2, look for the element 2 in the second array. So after element 2 there are no elements, so there is no greater element, so that we just need to return -1. So this is what the expected output. So is the problem statement clear? Okay, now how do you solve it? So simple, what he is trying to say, you will be given two arrays, so array 2 and array 1, and we need to find next greater element based on array 1. So but lookup should be done on array 2. So here you have element 4 in array 1, check element 4 in array 2. So after so element 4 is here. So after this, so do you find a greater element, greater than fourth element? So if you find greater than fourth number, then you can take that number, otherwise return -1. So when it comes to 1, so here you have 1. So when you move right, in the next element itself you find some number which is greater than 1, so pick that number. So that's how it is. How do you approach it? Okay, so if it is a brute force, for example, if you want to go with brute force approach, how do you do that? Can you tell me? So the constraint says all the elements are unique. So if you closely see here, all the elements are unique. So in the num1 and num2, all the elements are unique, and yeah, so whatever elements present in num1 will always be present in num2. So if it is a brute force way, if you want to solve with brute force approach, how do you do that? Can you tell me? Problem, is the problem statement clear, Kalyan Maithili?
Yeah, like traverse the first one maybe and then search in the second array.
Yeah, yeah,
Then compare the
that's it.
following elements of that.
That's it. So first of all, you pick up the element 4. Okay, so from first array you pick up the element 4. First verify where the element 4 is present. So here it is present. Find the next greater element after 4. So there is no next greater element, so that obviously it is -1. Now when it comes to element 1, then again move on to the second array from 0th index. So here you found element 1. So find the next greater element, so which is 3, so that 3 will be added. When it comes to 2, so again you traverse from 0 and somewhere you found 2 here, but there is no next greater element, so that obviously which is going to be -1. So it's a simple brute force approach. So what is the time complexity here?
N square.
Yeah, you cannot say it is n square, because the size of the first array is always smaller than second array. So assume that the size of the second array is m and the size of the first array is n. Then it is going to be n into m.
Yeah.
Let's say it is 3 elements, but it may have 100 elements, so 1000 elements, then it always varies. What is the space
But
complexity?
if we take a hash map and then try to
Yeah,
find that
we
element,
will
it can
come to
be.
that. Yeah, good thought,
Okay,
Ajay.
okay.
We will come to that. Okay, so What about the space complexity here?
What about the minimum? We can take that.
Space
No
complexity.
extra space. We are
No
Yeah.
taking.
additional space.
Yeah, so we are not taking any additional space, but we need to return the result, right? This
But
result is
suppose
size of the given number array. So definitely for result it is going to take big O of n. And for algorithm, so which won't take anything, so that it is going to be constant. Okay. Now what is a better approach? Okay, so just as I repeated, so what I can do, so what is the mistake we are doing here? So you have 4 1 2 in the first array, and you have 1 3 4 2 in the second array, right? So what are we doing here? So for each element we keep on traversing all the indexes, right? So we keep on traversing all the indexes. Somehow if you figure out the element index, so this is 0 1 2 3, somehow if you figure out the element index blindly, then you can just check on next elements, right? Because if you see 4, now if I know where the 4 present in the second array at index 2, so that I can look for next index onwards if I find a greater element or not. Yes or no? Yes or nobody? So
yes.
if that is the case, what I can do, first I will take this num2. So all the elements, okay, element 1 is at index 0, element 3 is at index 1, element 4 is at index 2, and element 2 is at index 3. Now let's see here. Now I just look for 4. Okay, where the 4 is present, index 2. So from index, then I will look on, I look from index 3 onwards, because I want to find out next element, right? Obviously I couldn't find greater element, so that which is going to be minus 1. Perfect. Now when I check 1, so 1 is at index 0. Okay, so I look for index 1 onwards. So at index 1 you already have greater element, take that greater element. Now when you go for index 2, so index 2 is at the last index, so that there are no elements to compare, so that obviously which is going to be minus 1. That's it. So can you tell me what is the time complexity here?
Order of n.
What of the
Can you think, is it order of n?
Because anyways we are traversing the first list, right?
Hmm.
For comparison, it is like constant time.
Yes.
But for traversing the first list, it's order of n.
Is always be constant and you figure out a greater element?
No. Sometimes we don't find it also.
Yeah, sometimes you don't find it also, right?
Yeah.
Let's say you have all ones here. So let's say my input is something like this. So let's say my first array is, so 4 4 4, and the second array is 1 1 1 1 1. Okay, okay, so 4 4 1 1 1 and so on. In that
But
case,
the constraint says that the first list is a subset of second, right?
yeah, so let it be, yeah, first list is a subset of second list, correct. 4 3 2, let's say 4 3 2. So do you find a, so what could be the time complexity here?
for loading it is big O of n.
Hmm.
For m, what is the maximum?
So
And then
yeah,
searching.
so
It will,
it is more or less, for the first element you are traversing m, for the second
yes.
element you are traversing m minus n, m
M.
minus 1, for the third element it is going to be m minus 2. So it is more or less same complexity, right? In worst
Yes.
case it is n into m, correct?
Correct.
And then what is the space complexity here? So we are using map, so definitely
Map.
which is going to be big O of m plus result, which is going to be big O of n. So there is not much improvement, but comparatively first one, so this will be better solution, because you don't have to traverse each and every time. Now to identify the index you don't have to traverse. Now let's move on to the optimal solution. So that's the concept of stack. So this is a concept of monotonic stack. So let's move on. So you have 4 1 2, and it is at 0 1 2 index, and you also have 1 3 4 2, so which is at 0 1 2 3 indexes. Now what is our task, buddy? What is our task? Can you tell me what is our task? What is our task? So we need to find out next greater element for a given element, right? Yes or no?
Yes.
So in the previous case, what we did, we have an element, but we didn't store the next greater element. We just store the index of the element, so that we have to traverse it. Now what I will do, I'll make sure that what is the next greater element for each and every element. So that's what I am trying to achieve. So definitely I need a map, because I want to find out next greater element for the next greater element for each element. So what I will do, I start from here. Okay, I start from index 2. So index 2 is the last element, so that the next greater element is going to be -1. Now sorry, not index 2, number 2. Now let's move on to next element. Now it's time for me to next element is 4. Now in a constant time I need to figure out, do I have a, so on an average in a constant time I need to find out, do I have a next greater element for 4. So that's what the concept of the stack. So what I do, so I'll just take 2. So 2 will be loaded into the stack. Okay, so for the first time stack is empty, so 2 will be loaded into the stack for element 2. So there is no next element, so value is going to be -1. So this is my map. So I am going to use two data structures. One is map, another one is stack. The map is containing the element and what is the next greater element for that. Now when I move on to next element 4, right, closely see, I need to find out, do I have a next greater element for 4. So what I'll do, in the stack, what is the element I have? 2, right? This 2 can no use, right? This 2 can there is no use of this 2. Do you think this 2 is useful? Do you think this 2 is useful for the previous elements with respect to 4? Do you think this 2 is useful for the previous elements with respect to 4?
No, but we get to know that by checking, right?
Yeah, just a minute. So what I'm trying to say is, so now I am at this index, right? I am having element 4. So I need to see for element 4, do I have a next greater element or not? So I need to see based on the stack. So in the stack I have element 2. So I understand that element 2 is not greater than element 4. So do I need to keep element 2 in the stack, or can I remove it? Ajay, Maithili, Kalyan.
We need not even check if it's greater or no, right? Like, because it's before 2, we can just pop the stack maybe.
uh, the point is I need to find out next greater element for each and every element, right? So that what I am doing, I am constructing a lookup map. This lookup map will contain the element and what is the next greater element for that. So yeah, you will get to know, I understand your question, but you will things will be clarified. So what I'm trying to say, I am at element 4. I understand that whatever next to this element will always be present in the stack. So that for element 4 the next element is 2, which is a stack. So what I'm saying, I can blindly delete this from the stack. Why? So I delete this from the stack because this element is smaller than the current element, so that I'll keep the current element 4. Why? Because when I move to next element, when I move to previous element 3, now I understand that. So obviously if you closely see, so for element 4 there is no next greater element, so that I'll just make it as -1. Now when I move to next previous element 3, now in the stack actually it was supposed to 2 elements, but in the stack you have only one element, because because you want to find out the next greater element, right? So immediate next greater element, it doesn't matter, you don't have to maintain all the elements in the stack. So that what you can do, this is my 3, so 3 next element could be present in the stack, so which is 4, which is already greater than 3. So that what I will do, I won't delete it from the stack, so I'll take the 3, so for 3 next greater element is 4, then I won't delete it from the stack, then I will add current element 3 to the current element 3 into the stack. Then when I move to the next element, now if you closely see the previous element, which is 1, okay, so for 1, in the top you have next greater element, so in the top you have 3, so 3 is greater than 1, so that I'll just maintain 3 into the I'll maintain for 1 next greater element is 3, so that I'll just keep 1 here. Now for example, if I have the input, so now if you closely see my map is containing an element, and what is the next greater element to that. So what I can do blindly, okay, I have element 4, okay, go to element 4, so in the map, so the next greater element is -1, just hold it. And for 1, so for 1 the next greater element is 3, so just take it. And for 2 the next greater element is -1, so just get that value from the map, that's it. So this is your expected output. Now let me take some interesting input so that you will understand the behavior of a stack. So let's say I have elements called 7, 2 and 3, and in the second array I have elements called yeah, let's say 7 and definitely 3, and I have 2, and I have 4, and I have 5. So let's say this 7, 2, 3 is already present. Okay, so this is the second array and this is the first array. Now what is our task? So we start from back, because if you start from right, you always it is always confirmed that last element doesn't have next greater element, so that for element 5 the next greater element is going to be -1, and you will also maintain that element in the stack. Now when you move on to the previous element, which is 4, so in the stack you already have element 5, which is greater than 4, so that for 4 the stack peak element is the greater, so that I'll hold 4 here. Now when I go to 2, and if you closely see, 2 is here, and let's take here 9 as well. Okay, so 2 is here, so with respect to 2, 4 is the greater, so that for 2 4 is greater, so I'll just keep 2 here. Now when I come to 3, right, when I come to 3, so now I will loop into the stack. Okay, first in the top you have 2, so 2 is not greater than 3, so that I will delete it from the stack, because there is no use, right? Then I will move on to the next element, which is 4. Okay, 4 is greater than 3, so that I can take that 4 and I'll add 3 to the stack. Why I deleted smaller element, so which is more interesting point. So why we need to delete smaller element? One is to find out what is the next greater element for the current one, and other use case is when the current element is larger than the next element, so that this current element is going to be the next greater element to the previous elements, so that you can always remove all the smaller elements with respect to the current element from the stack, so that way you can improve the time complexity. Now when I move here, when I move to 7, now if you closely see, 7 is smaller than greater than 3, so that this is deleted. 7 is greater than 4, which is also deleted. 7 is greater than 5, which is also deleted. Now if you closely see, my stack becomes empty. So when the stack is becoming empty, it means for the current element there is no greater element, so that you can add -1. Then what you can do, so you can just add current 7 to the stack. Now when you move on to the next element, which is 9, now if you see, when you are at 9, you don't need to compare all the elements, because after 7, so when you are at 9, so you don't need to compare all the elements, because after 7 whatever elements you see, all those elements who are what, all those elements are smaller than 7. So if some element present here, your job is to find out next greater element compared to the previous element, right? So all these elements are smaller, so that this is going to be the optimistic result, so that you can always delete all these values from the stack. So that's how you keep on deleting or increasing the elements from the stack. So that's the concept of monotonic behavior. Now when it comes to 9, so 9 is greater than 7, so that obviously this 9 is going to be the next greater element for the previous element, so that you can remove whatever element present in the stack. Again stack becomes empty, so that for 9 also there is no next greater element, so which is -1. Then obviously you will add 9 into the stack to compare if there are any elements in the previous. Now if you closely see, this is your map which contains all the elements. Now for 7 the next greater element is -1, because if you see 7 there is no next greater element. For 2 next greater element is 4, so that's what you could see here. And for 3 the next greater element is 4, that's what you could see here. So you can just write -1, 4 and 4. Now if you understand the algorithm, can you tell me what is the time complexity? First of all, do you understand the algorithm? Everyone, please. So, what is the time complexity?
Here also it will be n cross m only, right? Why? Because we are checking for the element.
This is where it needs very good observation. Can you think little bit?
It is order of m plus n, not multiplication. Because for the second one we are traversing anyways.
Mm.
That is m. But for
Mm.
the first list, when we do the lookup, that is a constant time.
Mm. So
But
more,
anyways, we have to
what
do,
is the costly operation you could see? Okay, so for acquiring the results, which is always going to be big O of n, we just look up from that.
Correct.
To construct this map, right? To construct this map, which is the costly operation, right? So which is the costly
Yes.
operation? So okay, so obviously you traverse all the m elements. Okay, so you traverse all the m elements, and do you see what is the cost of each element? What is the cost of each element? How many times an element can be visited in worst case? Maithili? Yeah, so Kalyan or Ajay, how many times an element can be visited in worst case?
Twice, maybe.
Perfect, right? So it's twice. Why? One is, if it one is first time it will be visited and added to the stack, and second time if it is smaller than the previous element and it will revisited and deleted it. If it is greater than, then it won't. So that an element can be visited only twice, so which is going to be 2m. So big O of, so one is for constructing the result big O of n, and it is going to be 2m. So you can say, to precise, it is 2m, but it is m. And the what is the space complexity? What is the space
Order of
complexity?
m.
For
Yeah, so
stack also we will calculate, is it?
yes, for stack also it will we will calculate. So for map,
Okay then.
which is
Map
going to be,
and stack.
yeah, so for stack also which is going to be m, right? Because everything is increasing order,
Okay.
everything is in decreasing order. Let's say 1 2 3 4, then definitely you always have all the elements in the stack. So that for map it is m, and for the stack also it is m, and plus for result which is going to be n. Correct?
Yes.
Others also clear, right, Kalyan?
Bit confused on time complexity.
Ah, so that's where, right? So what are we doing here? If you closely see, uh, in a stack, what are we doing? So when you are visiting the elements, right? So first we will add element, and if the element 2 is greater than element 1, then we will remove the element 1, right?
Yes.
So for example, you have 1 2 3 4. In this case, first we will add element 3, and element, it is just in increasing order. So if you closely see, I can simply say that for 4 next greater element is -1, and for 3 which is 4, and for 2 which is 3, and for 1 which is 2. So initially you will add 4, Okay, so 3 is 4 is greater than 3, so we'll just get it. So in worst case all the elements will be added into the stack, but in this case every element will be visited only once, right? Yes or no?
Yes.
So for example, if it is other case, so 4 3 2 1, then
One.
first 1 will be present, then when it comes to 2 1 will be deleted, when it comes to 3 2 will be deleted, when it comes to 4 3 will be deleted, correct?
Yes.
So all are minus ones only, right? In this case, even in this case also every element is visited at max twice, right? First while iterating, and other is from the stack, right?
Uh, yes.
So that's why it is 2m. Okay.
Okay.
Okay, so let me write the code. So now we have map, so definitely which is going to have two elements. I can say it as lookup map. So lookup, you can say new hash map, and I'll also have stack, which is just have elements, new stack. Then yeah, so what I can do, so I can just traverse from last index, so for the second array, so that I can have a lookup index greater than or equal to 0, index minus minus. And what is our job now? So I'll check, this is my current number, nums of 2 of index. So what I'll do, as long as my stack is not empty, and my stack value is less than or equal to my current value, then I can blindly remove it from the stack. That's it. Then what you can do, so now you need to find out a next greater element for this number, so that next greater element, you can say if the stack is empty, it means there is no next greater element for this element, so you can return -1. Otherwise you can take the top value from the stack. Then what is our job? So you got the next greater element to this element, so that you just add that into your lookup map. Okay, so this is my element, and this is my next greater element. Fine. So finally what you do, just add the current element to the stack, so that it can be useful for the previous elements. That's it. So once you are done with it, it's our job now. So I can reuse the same array, in order to create a new array. I can reuse the same array, integer index 0, index less than nums 1 dot length, index plus plus. So what is our job now? So you will have element here, element, you can get it from nums 1 of index. Now if you closely say, I'm using the same array so that you can avoid the space complexity here. So nums 1 of index equal to, from this lookup map, what is the element, next greater element, so you just pick that and add it here. That's it. So finally you can return nums 1. Clear? Code is clear? Yeah, so let me run. Yeah, that's it. So this is what monotonic stack. So what we did, so that stack size is keep on increasing and decreasing, right? So that's a concept of monotonic stack. Yeah, this is somewhat, yeah, this is, yeah, let's look at this problem. Okay, so what he is trying to say is, he has given uh, he has given a string, and we always need to pick unique elements from this string, and all the unique elements should be in lexicographical order, just like dictionary order. So let me explain the problem statement, which is CBA. Okay, so let me explain the problem statement. You have C, B, A, D. Oh, sorry. So what is it? So CB, ACD, and CBC. Okay. So this is the problem statement. What he is trying to, so there are a lot of twists in this problem. One is we need to get only, we need to avoid duplicate elements. Okay, for sure we should avoid duplicate, we should get only unique characters. And the problem statement, if you see the constraints, so it always has only lowercase letters. So this is one clue. So you always have lowercase letters. Let's understand the problem statement. You will be given a duplicate characters. You always, you need to return the unique characters, but the result should be in lexicographical order. So what does it mean? If you closely see, here, so you have C, right? You have C is already repeated, so that C can be in future. You have B, and B is already repeated, so B can come in future. So let me see, let me take the possible outputs here so that you can understand the requirement. So actually there are only four elements in this case. One is CB, A, D. So this is the, if you consider the order, so C, B, A, and D. That's it. So these are only the four elements, but this is not the expected output. They are expecting the output in lexicographical order. So let's understand what does it mean. So this is not expected output. So what he's trying to say is, uh, okay, so let's see here. If you closely see, C is already present in future, B is already present in future, so that I can take A. Okay, now you got A now. What do you mean by lexicographical order? So lexicographical order means the current character should be less than next character. So that's the lexicographical order. That's what he is trying to expect. For example, if you see, CBAD is a valid result. CBAD is a valid result, but when you see, when you are avoiding the duplicates, so C is already present in future, right? So it means C can be shifted to future. But if the C is not present in future and you don't have any option, definitely C will present here. But if you closely see, C is presented at multiple places. And it is not following, when you are avoiding the duplicates, which is not following lexicographical order. So which means C is greater than B, so that it is not expected output. That's why similarly, if you consider something like this, B, A, C, D, and this is also unique elements, but if you see here, B is already present in future, and if you consider B is greater than A, so that this is also not expected result. Then what I can do, so I can take A, so definitely I can take A. Then I can take CD, because C is less than D. Then I will only have B, so that I can consider B. So there are no elements to compare on B, so that ACDB is the expected output. Is the problem statement is clear, or did I made you confused?
No, not clear, Shinu. Can you please explain one more time?
Yeah. If the ask is just to avoid duplicate elements, then it is pretty simple. So if just to avoid duplicate elements, it is pretty simple. So definitely it is going to be CBAC. Either it can be CBAC, or it can be BACD, because it can be BACD, or it can be ACDB. So these are the possible. Strings you could.
CBAC won't be there, right? CBA or BACD, like that,
Sorry,
right?
yeah. Sorry, just let me take. So one output could be CBAD. Okay, CBAD. This one, and this one. Other output can be BACD. Okay, so BACD, and the other output can be ACDB. So ACDB. So if you closely see, right, this is invalid output. Why? Because we want to return when there is a duplicate. When there is a duplicate, we need to return the element in lexicographical order. It means if you closely see, C is already present in future, right? So C is already present in future. So we need to make sure that your string at max, your string should be the smallest string. So if you consider out of these three possibilities, right, I can say this is going to be the smallest string. Yes or no? Lexicographically, Ajay. So this is the smallest string. So in simple, he wanted us to return the smallest string. When there is a duplicate, so you wanted to return smallest string, so that this is going to be the smallest string. But how do you tackle that? So that's the question, right? So how do you tackle the algorithm? So with respect to problem statement, this is simple. So we need to return the smallest string by avoiding the duplicates. Now how do you tackle that? Can you tell me what are the thoughts you could get? Ajay, is the problem statement clear?
Yes or no? Just a minute, clear.
Yeah. So, can you tell me what are the possible solutions you could think of? So, one is C, B, A, C, D, C, B, C, right? How many? C, B, A, C, D, C, B, C. Okay. So, which is at index 0, index 1, index 2, index 3, 4, 5, 6, 7. Okay. Let me take into new screen. Okay. Now, can you tell me what is in your mind? You want to find out. You want to avoid duplicate elements, and at the same time, you should make sure that your string is always going to be smaller. Your resulted string is always going to be smaller. Can you tell me what is in your mind? What is your mind? What is in your mind? Okay, so let me explain. One thing for sure, I want to make sure that my resultant string should always be smaller. Should always be smaller. How do I make it smaller? How do I make it smaller? For example, let's say you have only C. Let's say you have only string CBC. So what could be the smallest string? So you have two strings CB and BC. So BC is going to be the smallest string, right? So in this case, the expected output is BC, right? Now, how do you know that? How do I generate a smallest string? So that's the question, right? So let's consider only this input, so that the other one will becomes easier. What I will do, I'm sure that I have only two characters here. So one is B, another is C. So B is at index, if I consider 0, 1, 2, so B is at index 1, and C, last index of C, which is going to be 2. So this is going to maintain the last index of each and every character, so that I will take a decision to generate a smallest string. So let's see how can I do that. So first I will start from index 0. At index 0 I have character C. So what I'll do, I'll keep this character into stack. Okay, so stack contains character C. Perfect. Now when I go to index 1, when I go to index 1, this is where more important point. So at index 1 I have character B. Now I will compare the character present in the stack. Okay, so the current character B, which is smaller than the character present in C. Okay, now I need to take a decision. Can I include this C into the stack or not? When can I remove this C? Can you tell me when can I remove this C?
If it is bigger than B.
So it means you have C here, right? And what is the current index you are iterating? What is the current index you are iterating? Index 1, right? because B is at index 1. Okay, so B is at index 1, and the stack you have in the value C, but C is present in future, right? Yes or no, buddy? C is present in future, right? Yes or no? So initially what I did, so I maintain a map or a hash, which will maintain each character last index. So C last index is 2. So what I do, first stack is empty, so that I just put the character C into the stack. Now when I move on to the next element, you have character B. Now I understand that, can I make a smallest string? How do I make that? Okay, current character B, which is smaller than C. Okay, so it is smaller than C, so that B is smaller than C. Now I need to take a decision, can I remove the C or not, right? So can I remove the C or not? So that's the decision I should take. I can remove C only if it is present in future, so that I can make a smallest string. If C is not present in future, for example C is not present here, in that case the expected output should be CB only, because there are no duplicate characters, so that you can blindly return CB. But if you closely see here, C is present in future, so that I can blindly remove it from the stack. This statement is clear, please. Kalyan Maithili.
Yeah.
Okay, so you have confusion, right? So the point is I need to generate a smallest string, right? So I need to generate a smallest string if there are duplicates. So what I'll do, so this is my stack. So initially what I do, I will maintain a map. So this map will contain the character and what is its last index. So B is at index 1, C is at index 2. Okay, so C is at index 2, last index of each character. C present at multiple indexes 0 and 1, but I will maintain the last index, so that I can take a decision to remove this element or not. So initially stack is empty, so that first I will take C. Okay, C will be copied into the stack. Now this is my current iteration, so stack is empty, so I blindly copy C, and the next iteration is 1. So I'm at index 1. At index 1 I have element B, and B is less than the top element of the stack. Okay, so B is less than top element of the stack, and whatever top element, whatever C is also present in future, so that I can blindly remove this to generate a smallest string. I remove it and I'll keep the small current element B. Okay, now I will move on to the next element C. Okay, I'll move on to the next element C. Let's take B also as well, B also here. So which is at index 3, so this is index C. So now I will move on to the next iteration, index C. So now C is greater than the top element of the stack, so that I can blindly put C, because it is always going to be the larger values, right? So that I don't need to do any operation. Now when I move on to the next element B, now the current iteration is 3, I am at B, and B is smaller than C, but should I delete this C or not? I need to take a decision. I can only take a decision if I have B's in future. So if I have B's in future, so but if you closely see, there are no B's in future, because I am at current iteration 3, and in the lookup map also B is at index 3 and the current iteration also 3, so that I don't have to take any decision. If I have future B's, then I could take a decision that I can remove. Sorry, I made you confused. If you closely see, I am at current index B, right? So current element is B, and the top element of the stack is C. So B is less than C. Now I need to take a decision. Can I remove this C or not? So when do you remove C? If you have future elements, right? In future, if you have C, then you can remove this C. But if you closely see, C is at index 2, but the current iteration is at index 3, right? So definitely there are no future C's, so that you should not take a decision to delete C. That's it. So when you move further, so you are done with it. So now your stack is containing C and B. Once you pop, it will have BC. You just need to reverse it. So once you pop it, it is going to return CB. You just need to reverse it, so which is going to be BC. So that is our expected output. Okay, this is a concept, but if I walk through this input, so you will get more clarity. But did you understand the concept? Ajay, Kalyan, Maitri,
Yes.
okay. So let me walk through this input so that you will easily get this. So what I'm trying to say, we are going to generate a smallest string, right? So that I'm going to make a map or hash. So it will have the character. Okay, so I have total 4 characters, right? A, B, C, D. Now let's say where is the A last index present? So A last index at 2, and C last index is at 7, and B last index is at 6, right? Is this correct? Yeah, so B last index is at 6, and where is the D last index is at 4. Okay, perfect. So you have these things. So first I am iterating here, please closely observe. So I am at here, so this is my stack, this is my stack. So in the stack you don't have any element, so that you will add element C. Now when you move on to the next element, so this is more important. Now you are at B, right? So now if you see B is less than C, definitely B is less than C. So can I include B or not? I just, can I remove C or not? I need to take a decision. I can remove C if C present in future. Yes, C present in future. How do you know that C present in future? Because your current iteration is 1, but C is at index 7. C present in future, so that I can blindly remove this C and insert back B. Okay, now stack contains only B. Now I am at index 2. Now at index 2 you have element A. Now again see that A is less than the top element of the stack, so which is B. So A is less than B. Now can I remove B or not? When can I remove B? If B present in future. So current iteration is 2, but B is at 6, right? So that I can blindly remove this B. Again I will insert A. Perfect. So now I'll move on to element 3. So yeah, so I'll move on to index 3. So index 3 you have C. Now C is greater than top element of a stack, so that definitely you can blindly insert C into the stack, because when there is a greater you don't need to take any decisions, right? Now when you are at element D, so now if you closely see, D is greater than top element of the stack, so that you can blindly insert D. Now when you move further, C, now you are here, right? Now this is our job now. So C, closely see, yeah, so now you are at C, right? So now if you see C is less than D, perfect. Now can I delete D or not? So when do you delete? If D present in future, but D is at index 4, but the current iteration is 5, right? It means D is not present in future, so that you should not delete D, so that you can blindly take C. But do I need to take C? Do I need to take C again?
No, we have already taken.
Yes, so
Already.
that we need to maintain a visited visited array. So when the element is visited, so definitely you mark it as true, and if it is unvisited you will mark it as false. So that in this case C is already visited, so that don't consider C, and again you move on to B. Now again B is less than D, but can I remove D? You can't delete D. Remove B, because you are at index 6, but D is at index 4, so that you blindly add B here. Now when you move further, C is already been visited, so that you can blindly remove it. So that's it. So now if you closely see, your stack is containing BDCA. So BDCA, so it's in reverse order, so you just need to reverse it. So it is going to be ACDB. So that is what the expected output. Clear, buddy? So more importantly, I forgot to update this visited concept, but you keep on. So if you remove from the stack, mark it as unvisited. If you add to the stack, mark it as visited. So that's how it works. So let me write the code so that you can practice other problems. And what is the time complexity here? What is the time complexity here? What are we doing here? Can you tell me what are the tasks we
Yeah,
are doing?
we are traversing the big list
Yes.
and creating the lookup one.
So one is
So that
we
will take order of
maintain,
n.
yeah, so we maintain last index of every element, so which is going to take order of n. Okay.
Correct.
Then we also
We
traverse the
visited one.
complete list again to generate a smallest one, so which is also taking order of n. And we keep on add and delete from the stack. So the stack operation also take how much? How much, buddy? Again, it is same, right?
Yeah, the
If it
worst
is,
case
if,
it can be same.
yeah, so in worst case you can revisit twice. Few elements you revisit twice, so it can be order of 2n. So this is for stack, and so yeah, so
Or visited one also we have
so we
time
have
complex.
visited one. So visited, of course, while traversing this itself, you keep on update that visited. So there is no change in it. So that's it. And what is the space complexity here? One is for this lookup, which is order of n, plus stack. So you can, if you, in case if you have all unique elements, which is going to be order of n, plus this visited, which is also taking order of n. Correct?
Yes.
So all are order of n's. This is something, it is very difficult to come up this solution for the first glance, but if you practice, other problems will become much easier for you. So what I'm trying to do now, you can use map or you can use array also, because it is always having 26 characters, right? So generally, if you can say the space complexity is always going to be constant. Why? The space complexity is always going to be constant. Why?
Because maximum there can be 26 elements.
That's it, right? So irrespective, even the input size is 10 power 5, the maximum elements in the whatever space you occupy, it always going to be 26, 26 and 26, right? So that the space complexity is always going to be constant. Sorry, so this is wrong. It's not n, so which is always going to be constant, but time complexity is n. So let me write the code. Okay, so what I will do, I will make use of array. So you can, this is my lookup array, integer array of 26 size, and one more boolean array, so which is for visited, no boolean array of which is also size 26. You can represent a character A with index 0, character B with index 1. So actually, if you closely see, A minus A, so what it does return? It will return 0 only, na? Yes or no, buddy? Yes or no?
Yes.
So obviously, so it will take ASCII values. I think it is how much? 96, right? So 96 minus 96, so which is going to be 0. Now if you say B minus A, then it is going to be, so which is going to be 97 minus 96, so which is going to be 1. So that's how it is. So if you write C minus A, so which is going to be 2. So what I'm trying to say, character A represented by index 0, character B represented by index 1, and so on. For example, if you say D minus A, so character D I'm talking about, so D is going to be around 99, right? So 99 minus 96, so which is going to represent index 3. So that's how it works. I'm just manipulating through that indexes. So let's move on, and I'm going to take a stack. So this is my stack of characters, stack, new stack. Okay, now let's move on. So index 0, index less than s dot length, and index plus plus. So let's consider the current character. So this is my current character, so s dot caret of index. Now there are two cases. So Prior to that, what you should do, you need to maintain the lookup, right? So the lookup index, let's mark it as, yeah, lookup index. So you have lookup of given character, right? So how do you get that index? So h dot, you can char ch equal s dot character of given index, right? Simple. So you can simply say whatever character you get minus a, so which is going to return the index number, so which is going to be this index. That's it. So you filled up the lookup thing. Then what is our job? Now again we need to generate a smallest string. So let's do that. First let's get the character. Okay, so I'll get the character. Then when do I delete from the stack? So there are ways. So if stack is not empty, okay, if it is not empty, then if you closely see from the stack dot peak, you get the latest character, right? So if the current character is less than the stack dot peak, okay, so this is also clear. And and what is the next thing? So and if this character is also present in future, okay, so in the stack you have a large character and that character is also present in future. How do you know that? So on the lookup you can get this stack dot peak. So on this lookup you can get the stack dot peak. It will return the character and minus a, which is going to return the index, whatever value it present, right? So whatever index it is present, if it is greater than current character, okay, so sorry, current index, so it means it is present in future. So if it is greater than current index and it is present in future, so that you can blindly remove from the stack. Is this clear, buddy? This is more critical part in this algorithm. Other than that, everything is smooth. Is this clear, Ajay, Kalyan?
Yes.
Yeah. Done. So we are done with the logic. Then what is our job? Finally, you can push this to the stack. You can push the current element to the stack. And what is our job now? So we will just iterate from the stack, return the reverse of it. That's it. So finally you can simply return a reverse of it. Yeah. Let me run it. Let's see what is it. Duplicate. Yeah, so it is given duplicate. So tell me what is the mistake. It is given duplicate C.
Have we visited? Maybe
Yeah,
made
so
it false or
we didn't maintain that visited thing, right? So one is, so definitely you will add this character, right? So visited, right? So yeah, so visited, this character index you can mark it as true, okay. And also whenever you pop it from the stack, right? So you are popping it from the stack. So when you are popping it from the stack, then again you mark it as unvisited, so that I can take character, last character. So again you mark this as unvisited. So because if it is present in stack, then only you mark it as visited. If it is not present in stack, so it can come in future, so that you can mark it as unvisited. And more importantly, if the character is already visited, you can say if the character is already visited, you don't have to look for it again. So if it is already visited, so you can simply continue. Is this clear, buddy? Line number 21 is more critical part. That's it. So yeah, it's a pretty conceptual problem, but if you solve that problem right, I think you can solve. Please give a try for next two problems, and you can execute the sample test cases for problem number this one 735, but it is very tricky problem. If you want, we can discuss it tomorrow. But give a try for next two problems, which are more or similar to the current problem. A slight variation. So please spend some time. You will definitely get it. But probably tomorrow we will look for other problems. Clear? Or do you want me to explain? Or is it enough now?
We'll give it a try,
Yeah. If I read through the problem, you will get it. So, but if you read it and get it, so please solve it so that you will be confident in monotonic stack concept. We can solve further problems tomorrow. That's it. So